First of all, I'm so impressed with this team of students and from Kathmandu for organizing this. I decided to put up my first slide to express my happiness and support for this great event. You know, there is saying that behind every able person, there are more able persons. And I've seen a great team, able team of basically KU organized team. And I'd like to express KU and the organizing committee for giving me the opportunity for sharing a few thoughts in the form of keynote motions. And once again, I'd like to thank you for all the participants who made it possible. Okay. Now, you know, at the topic of my presentation, short presentation, indicates it's between interface between man and nature. You know, I'll try to talk about the basic fundamental issues because we're all interested in energy efficiency buildings and energy efficiency, energy enhancement, energy issues. And there are a lot of research going on in Kathmandu University and Tribhuvan University in Nepal and international area for energy related issues. So I feel we need to grasp the basics of it. So I'll try to present certain, highlight certain issues related to the basic without getting into too much detail. There are so many issues that it's just not possible, humanly possible to get into the detail. So I'll sort of scheme from top to get a overview of the issues. So to start with, you know, the problem lies in the interface between human and nature. For instance, take nature, take environment, and for some time, imagine there are no human present. Environment minus human, there is no issue at all. We saw in this last early days of lockdown due to COVID-19 that when everybody was locked down in most of the countries, there was no issue with the nature. The air became, even in Nepal, the air became cleaner. Ganges became cleaner in India. People could take bath in Haridwar. So leave alone nature and there is no issue. And for a moment, just consider human beings and there is no issue either. The only issue comes when in the interface between human and nature. We, by our very nature, we develop, we prosper. As you said, we are the most efficient species. The efficient human beings are one of the species which can talk about wisdom. No other species can talk about wisdom, and they cannot talk in abstract term. And we develop. So our development field is the nature. This is what we play with, and every development aspect affects nature in one way or the other. Good things, bad things, everything affects nature. So that interface is very important, and we need to understand the nitty-gritty of those interfaces. So let's kindly focus on this slide. You can, if you would see the Earth, our planet, the way we are living, as a system and consider the upper atmosphere as the system boundary and think for a minute whether it's an isolated system, open system, or closed system. Obviously, this is not an isolated system because we're getting energy from sun. And it's basically, it can be modeled as predominantly as a closed system. If you ignore small mass transfer like hydrogen leaving the upper boundary, or the meteorites, or the satellites leaving, rockets leaving the boundary, etc. If you ignore that, we can model it roughly as a closed system. So energy in from basically primarily from sun, although we may be getting radiation from other stars and all, but compared to what we get from sun, we can safely ignore that. So capital E in is basically from sun, and E out is the Earth's radiation beyond the atmosphere. So within the Earth, there are two kinds of energy. One is finite sources of energy like petroleum, coal, etc., etc., and these are finite sources. Now, as a student of engineering, we know in a system, anything finite means it'll end at some time. It's not infinite. And another other thing is there system generated energy, like wind, like current, like tides. So there basically we're looking at two systems of energy. One is finite source of energy and system generated energy. Okay? And we can treat our Earth as a small, compared to the galaxies, which is a small system in which we live. Now, I'll try to remind of our basic fundamental laws of physical laws. Obviously, the first law of thermodynamics, the change in internal energy is heat added minus work done by the system. And its corollary says that energy can neither be created nor destroyed. You can only convert from one source to another. And then there is a Carnot efficiency, which tells us that even if you invite Brahma, Vishnu, Maheshwar to give you everything you like perfect adiabatic expansion, perfect isothermal expansion, compression, frictionless space, etc., 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 there is a limit to what the thermal efficiency you can achieve between any source temperature and sink temperature. No amount of research is going to change this. This is a limitation nature has given us to live by. And then there is a very important law, second law of thermodynamics and entropy, which says that usable energy becomes less and less available as a result of real processes. So on one hand, we have finite sources, and another and the law says you can only have energy from one source to one in a form to another. The potential energy of the finite sources, like that of coal, like that of oil, we're using to drive our machines, to drive our systems. And then the second law says that as a result of your processes, the less energy will be less and less available because of the entropy will increase. And then there is theory of relativity, H equal to mc squared. We're not directly related with it. So I'll just concentrate on this second law. These are the two laws which defines our sphere of activity. So whatever energy game we do within these laws. Okay, this is the financial, this is the technical limitation. And then are there any limitations? Are there any advices? Because the moment we say everything depends on the interface between Earth and human environment and human beings. So is there any norm on how we're supposed to behave as human beings? We're a very important part of this nature, or how we're supposed to be. Is anybody telling us? These physical laws tell us in the physical domain. Are there any other laws which tell us? I'll show you, before that, I'll show you how much we are in communication with nature, human body nature interaction limits. Of all the frequency range, we hear between 20 hertz to 20 kilohertz. That's our range. Okay, we don't hear 10 hertz frequency. Actually, as a matter of fact, you can buy a dog whistle, which operates beyond this our hearing range. So when you blow, and if you train your dog to respond to it, the dog will come to you, but people, your guests and your friends will not hear anything. So this is our one limitation in hearing. We need at least more than 2. These days, doctors are saying that we need to have at least 3 liters per day of water to get this system functioning properly. Okay, and we need about 0.65 meter cube of hydrogen per hour. Need protein, carbohydrate, fats, and other vitamins, etc., to keep it going. And at rest, we're losing 50 grams of moisture at rest. We're losing. And with this oxygen, we'll lose 0.2 meter cube of carbon dioxide we're releasing, 0.02 gram per kg per day. This is solid waste. Water 1.5 liter per day. And the body is releasing 100 kilocalorie per hour at rest. Now, if you are in a disco or if you are dancing, this value will go high. But with all these limitations, there's a mechanism keeps operating temperature of this human body system at 37 degrees Celsius, plus or minus some. So this is a remarkable, from an engineering point of view, if we say define our human body as a machine, it's a wonderful machine, but at constant integration of mass and energy exchange with the nature. So this shows our dependency to the nature. Now I'll come to my earlier point. What is do we have as a smartest species? Has anything given us instruction on how to deal with the nature? So even before that, everyone has carbon footprint, some small one, some large one, depending on the lifestyle. Myself, your, and our colleagues, we spend certain amount of fuel per day, right? We use certain amount of transport, depending on where you study and live. You need to spend certain amount of electricity. How much waste do? You buy canned foods, bottle packed foods, or you buy from vegetable market. So these all add up to our individual footprints, carbon footprints. And these carbon footprints means they're directly proportional to the carbon dioxide emitted eventually in the atmosphere due to the action we do, right? Even if I buy a packed food packed in paper boxes, that paper box had to be built somewhere. And the manufacturing process took some process, and that released some carbon dioxide. So this is collectively we call it footprint. In the world, they say the Americans have the largest footprint because they use a lot of material. Asian countries have almost half of what a typical average American footprint is. Now, human population growth. The cause is the population growth. See, in 1750, the population was less than 1. This is estimated by United Nations. 2017, population is 7.5 billion. Now it's more than that. So it's like, lots of people living in a small house. And imagine we all have carbon footprints, and this adds to the burden in the nature. So now come to my earlier question, is there any guidance? So normally, what we do is if we seek guidance in the spiritual documents, and it's very interesting to note that there are each major spiritual document has some guidance. I've quoted, these are not the exhaustive, I've quoted just for example, some guidance from Quran, Bible, Gita, and Ramayana. The Quran says, eat and drink, but waste not by excess, for Allah loveth not the wasters. This is from Quran. And in Bible, you shall not pollute the land in which you live. For blood pollutes the land, and no atonement can be made for the land for the blood that is shed in, except by the blood of. I mean, this is biblical language. But the bottom line is, you shall not pollute the land on which you live. Okay? Now come to Gita. In chapter 10, Krishna, while he was telling Gita to Arjun in the battlefield, he gave an example that I am Meru, that's among the mountains. Among the unmovable things, I am Himalaya. Large ocean water bodies, I am ocean. Among people trees, were people trees, I am horse, I am elephant, I am cows, I am snakes, I am month, I am season. So obviously, when we read I am people, we don't go back and ask, oh, okay, then what is pine? You are not pine. No, these are just the symbolic sayings. That means everything is sacred. And during Quran time, Bible time, Mahabharata time, there was some pollution. You might be wondering why I put these two photographs. These are from Ramayana time. Imagine the time of Ramayana. It's like somebody moving into our new house for the first time, newly constructed apartment or building. There is no problem with the house. The plumbing system is working, electricity is working, no Dodeco, spark plugs, everything. During Rama's time, that was the scenario. If Rama had talked about pollution, nobody would understand what is pollution, what he's talking about. What is meant by pollution? What do you mean by pollution? So instead, he set up an example, which is normally what we do is we just read it and gloss over like a story. But if we delve deep into it, there's a profound meaning. The example is at the time one is about to cross to Lanka. At that time, the Sita is discovered. Hanuman goes to Lanka and finds Sita is imprisoned by by Ravan. And at that time, Ram has a problem going to Lanka. And in such a crucial time, he spends 3 days praying to the ocean to give passage to Lanka. Now, somebody who has capacity to go from, who is deemed to be king of Ayodhya and in going to fight Raman, is smart enough to understand that water will not give way just by praying. But why did he spend 3 days? That is to just set an example on how to behave with nature. So at the end of 3 days, obviously nature won't give, and it just says, bring my bows, I'll dry it up. And then the sea comes and prays, sea, and the dialogue is very interesting. If you go to Ramayana and read that, the dialogue says, because of the attributes you have given to me, the water, I cannot give you passage. Change the attributes and take the road. And then Rama says, okay, no problem. Then he made. So he spent 3 days trying to set up an example. So this is Ramayana, Gita, Quran, Bible, all setting an example on how to behave with nature. What is the example? Behave with utmost care while you're dealing with nature. That's simple language. If you had just said that language, nobody would understand. But with this drama, 3 days long drama, we can decipher the meaning why that was munched. Now come to the technical issues. Now we'll look at it. What we're doing, we're still using the coal. See, this is 219 world, our world data. Luckily, coal has slightly decreased. Traditional coal has slightly decreased. Coal, oil, still these renewables are very small compared to the finite energy sources we're using. So we're predominantly heavy use of finite sources. So what about the entropy? How long we can continue good? What will happen after 50 years? What's in the next century? That's the big question we as scientists and engineers are faced with. How do we ensure that this system, Earth system, will be still alive and happy for our children at the time of our children? Okay, so these 34% is oil, 27% coal, 25% gas. See, basically we're still using the finite sources of this. If you look at the macro picture, this is the real issue of man-nature interface. We need to develop, fine. How do we develop? We're using the sources of energy, fine. There's no issue with it. But there are some consequences of how we're using that. I'll come a little later. But the problem is, this is not going to last us forever. So this is the real challenge for us. And then now we say consequences. What are the consequences? Look at the atmospheric carbon dioxide, CO2. 1970, this was around 322 something. By the time we're going to 220, look at this slope. This is almost 40 degrees, 45 degrees, 45 degree slope. Can we sustain it? Is our body system designed to operate in predominantly carbon dioxide environment? And our weather system operate in it? So these are the consequences of the way we are using the energy. That's what I call man-nature interface. Are we using it properly, or obviously there is some problem. There's some problem in the way we're using it. So what do we do about it? Then there is another thing, ozone depletion issue. Now, if you look at this is Dobson unit. This historical threshold is 220 Dobson. So if you have this color, slightly whitish, then traditional ozone layer thickness is maintained. But 79, it was good. By the time it was 84, the ozone hole started developing, and these are taken by 1979 through 2019 measured from NASA's STORM satellite and from OMI and OMPS. Here are the measurements. This data is from NASA. And 1990, look at the ozone hole. Dobson unit 100. Tragically, and the resulting is that it affects sea plankton, it affects our skin, it affects even the paints and all those things. Cataracts. Okay, look at 1998. And these are some of the major consequences of how we are dealing with energy. Now, what caused this? How can we continue like this? Can development continue without excessive use of finite sources? Now, there's a question, excessive use. Now, we have to be smart enough to decide what is excessive use. What constitutes excessive use? Nobody is advocating that we stop using these finite sources. But if we reduce, we have to reduce its use till the time when we don't need to use these finite sources. We need time to research, develop renewable sources and other sources, freely available non-finite sources, non-finite with the quote. And the second question is, can we repair the planet? The damage already done. And the third question for us engineers and scientists, how do we go about it? Already, right? We have already damaged our home by our ignorance or reckless practice or whatever you call it. But how do we limit it to the value which can be safely used till we find other substitutes? The causes. Now we need to look at the causes. What caused it? One of the reasons why it happened was ignorance. During the course of development, during the industrial age, everybody was happy, industry was growing nicely, things were being produced. At that time, nobody knew that it would give rise to greenhouse gases. That was pure ignorance. Now, similarly, ODS, the ozone depletion, these refrigerants like R11, R12, R22 is one of the excellent refrigerants from the thermodynamic point of view. Nobody, till we knew they were the primary causes of ozone depletion. So that's it. There is the basic fundamental is ignorance. We are developing. We as human beings are developing, and they still don't know many things we don't know. So we cause damage due to ignorance. Okay. Second is our greed. Now this is very important. Greed is not only limited to person, a community, family. It is limited to country. Overfishing. Now the countries who fish know that they cannot finish the school of fish because they need to come back and fish the next year. But they are not hitting. They are not hitting. Poaching of animals, excessive felling of forests, they are due to a human greed, and we need to mature. After this understanding will make us mature. Then there is excessive demand on material growth, even beyond the necessity. There's unbridled consumerism that I'll come a little later. Now, I've taken a very simple example. Now, as smart guys, smartest species, we need to think, put our brain to think that what is normal? If you look at television, they say they want us to buy one mobile, a new set of mobile every year. They want us to buy car every year. They want us to buy this every year. They want us to buy this every year. So who is setting the normal? The advertising companies? Are the manufacturers telling us what to do? Who is doing it? Who is deciding what is normal? These are the basic behavioral issues. And the question we need to ask is consumerism proportional to happiness? Like I showed earlier, that footprint. How much footprint I need to increase to become happy? I have taken the most simplest example of shoes. You want the simple example on then all juta. Juta one the sano example keeping juta. कति जोड जुत्ता भयो भने तपाईँ म खुसी हुन्छौँ कति जोड जुत्ता घरमा भएपछि we make it happy. Let's start thinking by that simplest of the things, chappal and jutta. An example, how many pair of shoes do I need to make me happy? The first question is, does having 10 pair of shoes, one for one party each, make me happy? Make me perhaps. But on deep thinking, you know that these are conveniences only. They're not proportional to happiness. Having more material doesn't give you more happiness. They make your life easy to an extent. If you have 4 pair of shoes for different occasions, fine. There's no point in increasing it to 40. Even convenience-wise, that's not necessary. So, but each additional pair adds to my carbon footprint, and that is haunting the atmosphere. It is damaging the house we all live in. So each person, community, and country should aim to reduce the carbon footprint through appropriate use of energy. Okay. What are the approaches? Then they said, okay, we can repair. So corrections of mistakes brought about by ignorance for international effort. Research and development. That's what this. I've seen what papers are being presented today. Very good research works, very good efforts. This is where we come in. We fit in research and development. And then there are national policies, the government fits in. I mean, obviously, we feed the government. So we fit into these two, research and development. As a researcher, this is our primary duty, research and development. And As a secondary duty, we give advices to the governments, local governments, and national governments. And then, as a government, we give advice to the United Nations and UN bodies to bring about the changes. And educational and awareness at national community level to bring about the behavioral changes. Towards cleaner energy, what we need to do, reduce energy loss. We're wasting huge amount of energy. Believe me, I'll show you with a very simple example. We're wasting energy. And we need to enhance system efficiencies. I know KU has a turbine testing laboratory, product design change. It could be achieved through product design change, efficiency, giving ratings on products, efficiency enhancement from design and material change, smart controls. And develop technology for utilizing new sources of energy. I know KU and Nepal Oil Nigam has come in, have MOU or contract for trying to use hydrogen as alternate energy. This is the kind of thing we need to develop to keep track of the energy, to ensure development and also ensure the life of the earth both at the same time. And of course, there is the behavioral changes. I'll come a little later. Now, I said there is huge wastage. I'll give you an example. The Energy Research Institute, Delhi of India, through a study determined that my example is a very simple example. 1.5 ton air conditioning unit is a very small air conditioning unit. A 5-star rated, you know that they can rate instrument, yellow, green, 5-star rated. There was a study done in India for a city in Delhi, operating 10 hours a day, a saving of Indian rupees 6290 annually would be achieved if thermostat setting is increased from 18 to 27. It will still be 3900 if it is set at 24 degrees, just for 1.5 TR, single unit of air conditioning. Now, what is happening in our country? You go to offices, you go to Singadarbar or any other office with air conditioner on. You even go to this is your heating season, go there, the people are there, AC is running or heater is running, and then the doors are open. Nobody bothers to close the door. Now, it's a crime against earth to keep burning the fuel and letting the cold air come into the room. And you might say, I can afford. No, sir, I do not agree with you. You cannot afford. You cannot afford. Nobody can afford that in today's earth. If you had only, say, 2 persons, just imagine if you have a husband and wife living in four-bedroom house, then you can afford to live everywhere, anywhere. If you have 3 children, then you cannot afford to live everywhere. It's like going in a plane which is not full. You can change your seat. If you're going in a transatlantic flight, long flight, at night you need to sleep. I've seen people do that. Unfold the middle seat, sleep. If the same flight is full, you cannot even move from one seat to another. Now Earth is full with us, full with people. We cannot afford to do this. So in general, there will be saving of 3 to 4% power for every degree thermostat. And we do not need 18 degrees Celsius. I've seen people the moment you go in summer, the first thing they change, put the thermostat to the minimum. And in heating season, they put the thermostat to the maximum. We have to be smarter than that and think that it's no more affordable. And I need to, you see, saving of 4 kilowatt hour per day would be achieved when thermostat is set to 27 instead of 18 in that scenario. It may be 3.5 or even more than 4 for different cities because of the ambient temperature, but it shows the trend. So in that case, if 1 lakh unit household, 1 lakh households using such unit, 1.5 ton, I'm not talking about big things. Thermostat instead to 20 बाहिर 34 भयो भने 27 डिग्री सेट गरे भइहाल्यो नि 18 मा सेट गरेर 20 मा किन बस्नु पर्यो that's the issue as 27 if you set it at 27 instead of 18 you could see 1 lakh people do that you would save 344168000 calories per day that amounts to saving of 60 tons per day of coke for electricity production 1 ton यदि 1 लाख मान्छेले 18 डिग्री को सट्टा 27 डिग्री में थर्मोस्टेट सेट कर दियो भने सिंपल स्मल यूनिट को 1.5 टन को मात्र मात्र ठुलो को त पुरै गरेछ नि त्यो गर्यो भने it will be equivalent to saving 60 tons of coke कम भए पनि हुन्छ किन त्यति इलेक्ट्रिसिटी कम लाग्छ so this could and then consider the reduction of carbon dioxide production that's simple method this is only saving whatever I mean not talking about a larger thing just think what will happen in offices you know in AC in air conditioning that takes about HVAC takes about 70% of buildings load now high-rise buildings are growing in Nepal so if you have a generator set of 500 kVA the 350 kVA would be required for HVAC only so if you do not save power and waste it, you're not doing good service to the earth. Now, Indian Bureau of Energy Efficiency Minister of Power has recommended guidelines. See, all consumers of commercial buildings are suggested to maintain the internal temperature between 24 to 25 with appropriate humidity and air flow consumption. They have already done the research, done the study, and come up with this is their policy issues to bring about the behavioral change. Nobody dies if he has to sit in office at 27 degrees. But nobody needs 18 either because it affects the earth. Okay. Now, this is many US has done that, and our neighbor India, which has more or less many similarities in terms of weather and other behaviors, they have already done it. And these guidelines, this is not for private buildings. These guidelines are mostly applicable for large premises such as airports, hotels, shopping malls, offices, and government buildings. You know, the most thermostat setting mismatch is in our office buildings, government buildings, because the people who occupy the seat, table inside the buildings, perhaps think that, okay, I can afford. No, sir, you cannot afford. If you think you can afford, you're mistaken. You're using the resource of the earth. That belongs to everybody. So obviously, these recommendations are not for hospital use or operation theaters like that. These are for general areas that have already come up with the code. And this is Bureau of Energy Efficiency. Look at the date. In this regard, 11th and 19th Technical Committee meeting of air conditioners on 19th March 2019 and 21st May 2019 respectively follow. They have gone to the extent where default temperature setting for air conditioners 24 degrees Celsius for the optimal temperature setting guidelines. The default setting of the thermostat means that whenever the new air conditioner is switched on by the reverse, the setting goes to 24 by default. So they have gone to this extent to conserve energy. This is one area we need to look at it, we need to do research, more work, and come up. And here is a success story. I had put this thing already, but I didn't talk about it. This Montreal Protocol is deemed as the most successful international environmental effort. The countries gave trainings to customer officials in recognizing the ozone-friendly refrigerants. As expert, we trained our customer officials at that time to how to recognize the refrigerants at the point of custom points. And so with this, and we trained our refrigeration technicians, and this is one of the most, as of now, this is the most successful international effort. And September 30, 2005, my Ozone Hall, Now you have seen the recovery in 2019. So, Hundorecha, we can do it. Even such a thing as ozone layer, we successfully reversed the damage. So this is a good story, but greenhouse gases, carbon dioxide, there's no such thing. The Kyoto Protocol and other protocols, there some countries have not signed it, and there are many issues why they haven't done it. But the fact is, we have not been successful. In this case, this is the only UN treaty that has been ratified by all the countries in the world that are members of the UN. So I'm about the last slide, the challenges and immediate promises. So that our challenge is to try to use these sources of energy. We're using a lot of gas. Now, nuclear is hazardous, may not be advisable. Hydropower use is still low. So there is a turbine testing lab in Kathmandu University. Maybe perhaps you can come up with a small scale turbines that can use low discharge and low head. And if you have, lakhs of such turbines and distributed all over the country, then we would be in better shape. Now, hydrogen fuel work is being done in KU, and these are the areas challenges where we believe our scientists, our students, when they're doing research, they'll come up with the solution to these problems and help serve the planet. Thank you.